This is the video that goes with Chapter 7 on using addition rules for trigonometry. Now, the addition rules are a way of reminding us how we distribute a trig function, sine, cos or tan, over a sum or a difference. Now, some students think if I have something like this, sine of 60 degrees plus 30 degrees, that is the same as sine of 60 plus sine of 30. But unfortunately, if you work out those values, those are not true. We can't just expand like we do normally with, say, multiplying by 2, because of course sine is a function. So the addition rules, which are given to us in the formula book, and there are 6 rules here. And what you do is you follow the signs. So I'll do some highlighting. So if I wanted to expand sine of A plus B, that would give me sine A cos B plus cos A sine B. So I'm following the top line. But if I wanted sine of A minus B, that would be sine A cos B minus cos A sine B. Likewise, for the cos one, if I wanted cos of A plus B, that's cos A cos B minus sine of A sine of B. And again, I'll just change colour. So if I wanted cos of A minus B, that's cos A cos B plus sine A sine B. And the same for the tan one. If I wanted tan of A plus B, that's tan A plus tan B over 1 minus tan A tan B. And the last one, tan of A minus B, is tan A minus tan B over 1 plus tan A tan B. So we can use these rules to help us to distribute the sine function. So let's just have a look at a few examples. So the first one says, without a calculator, evaluate sine 40 cos 20 plus cos 40 sine 20. So what we need to do is we need to find one of our addition rules that matches up with that. So the one we're going to use is sine of A plus B equals sine A cos B plus cos A sine B. And if you compare what we've got here with what's on the right hand side of the addition form, you can see that they match up, where A is 40 and B is 20. So therefore, if I put those into my left hand side, I get this is the same as the sine of 40 plus 20, which of course is the sine of 60. Now, using your special triangles, you should know that the sine of 60 is root 3 over 2. Okay, now the next one we're going to look at is 2 cos 60 cos 30 plus 2 sine 60 sine 30. So the first thing I'm going to do is I'm going to take out the 2. So it's 2 lots of cos 60 cos 30 plus sine 60 sine 30. Now I'm looking for a formula that goes cos cos plus sine sine. And the one I'm going to use is cos of A minus B, because that's the one that goes cos A cos B plus sine A sine B. And again, if I compare what's inside the bracket with what's on the right hand side of the formula, we can see that A is 60 and B is 30. So in order to work that out, I'm going to substitute those in, so I get 2 lots of cos of A minus B, so that's 60 minus 30, so that's 2 cos of 30. You should know that cos of 30, of course, is root 3 over 2. This is 2 lots of root 3 over 2, which is root 3. The next one, if you look, you can see it's tan 20 plus tan 25 over 1 minus tan 20 tan 25. So again, I'm looking for something that looks like that. Again, if you look in your formula, you'll see you've got tan of A plus B, so it's the addition of tan is tan A plus tan B over 1 minus tan A tan B. So again, if you compare, this time I'm going to use a highlighter, 20 corresponds with the A, the 25 corresponds with B, and the important thing is the sign in the middle. They correspond with each other. So therefore, I can see straight away that A is 20, B is 25. Therefore, if I substitute those in, it says the same as tan of 20 plus 25, which is the tan of 45 degrees, which of course is 1 using your special triangles. Now the next question, we're going to use the work that we did on exact angles. So we are told that sine of A is 3/5, sine of B is 5 over 13, where A is acute and B is obtuse. So if you remember back to our work on exact values, the first thing I'm going to do, I'm going to draw my right angle triangle. There it is, and there's A. And of course, from this piece of given information, sine A is 3 over 5. That tells me the opposite is 3, the hypotenuse is 5, and therefore the adjacent must be 4. Now sine B, again, I'm going to first of all pretend that B is acute. So in order to get my ratio, so again, opposite is 5, hypotenuse is 13, that means the adjacent is 12. But if you remember using your cast diagram, okay, your cast diagram, C, A, S, T, 90 to 180, only sine is positive. Okay, so from the first triangle, I can get that cos of A is 4/5, and because A is acute, the ratio stays positive. From the second triangle, I can get that cos of B is, well, if it was acute, it would be 12 over 13, but of course, because only obtuse angles between 90 and 180 sine ratio is positive, this must be negative. Then I want to work out the exact value, and of course sine of A plus B is sine A cos B plus cos A sine B. I'm going to put in what I know, that sine A is 3/5 multiplied by cos B is negative 12/13, plus cos A, of course, is 4/5, and sine B was 5/13. If you get your calculator to work that out for you, you get negative 16/65. So that is the value of sine of A plus B. Right, let's have a look at another question. So we're told if tan of A plus B is 1/7 and tan A is 3, then find the value of tan B. So the first thing I'm going to do is I'm going to start with the formula for tan of A plus B. So that is tan A plus tan B over 1 minus tan A times tan B. I'm going to put it with what I know. Now I know that tan of A plus B is a 7th. Tan A, of course, is 3. So that's plus tan B over 1 minus tan A, of course, is 3 lots of tan B. You need to just solve that equation. So I'm going to cross multiply. So I'm going to get 1 minus 3 tan B equals 21 plus 7 tan B. Everything onto each side, so you end up with 10 tan B equals negative 20. Therefore, tan B must be negative 2. And so all you're doing is putting in our values. And the next one says, prove that sine of 2x plus y plus cos of 2x minus y over sine y plus cos y is identical to sine of 2x plus cos of 2x. So again, because it's an identity proof, I'm going to start with the left-hand side. And the left-hand side is sine 2x plus y plus cos of 2x minus y over sine of y plus cos of y. So if you look in the top, I'll use a lighter highlighter, you've got two expressions that look very similar to sine of A plus B and cos of A minus B. So we're going to use the A plus B formulae to expand these. Okay, so I'm going to put those in. So the first one, I'm going to expand. So I'm going to sine of A plus B, so that's sine of A, which is 2x, cos of B, which is y, plus sine, right, so that's cos of 2x sine of y. And then the second one we're going to expand, so this is cos of 2x cos y plus, because don't forget the cos, the signs are opposite, and it will be sine of 2x sine of y all over sine y plus cos y. Now, if you notice on the bottom we've got sine y plus cos y, so it might be a good idea if we can pull out sine y cos y as a common factor. Okay, so right, might be a good idea if we get the same terms together. So I'm going to, I'll just do it in red, have this term, and I'm going to pull this term together on the top. So this is sine 2y cos of y plus 2x sine of y. And then I'm going to put these two together. Now you could have done this in one fell swoop, but I want to just make sure everybody's happy on that one. So this is plus cos 2x sine y plus cos of 2x cos y. And again, that's all over sine y plus cos y. If you notice the first two terms in the numerator, I can pull out sine 2x as a common factor. So I get cos y plus sine y, and then pull out cos 2x as a common factor from the second two. So I get sine y plus cos y. Okay, and again, that's all over sine y plus cos y. Now we can do some cancelling. Okay, This cos y plus sin y is the same as sin y plus cos y, cancels with that one, but it also cancels here because remember it belongs, the terms in the denominator belong to both terms in the numerator, and therefore when you cancel those down you're just left with sine of 2x plus cos of 2x, which of course is the right hand side. Right, we're going to look at this question here, right, and I've prepared the diagram. Really important that you draw a diagram for this one. So it says the lines L1 and L2 with equations y equals 2x and 3y equals x minus 1, which of course is the same as y equals x over 3 minus a third, drawn on the same set of axes. Given that the scales are the same on both axes and the angle L1 and L2 make with the positive axis is A and B respectively, write down the value of A and the value of tan A and the value of tan B. So again, if you look at this, the first triangle where I've marked A, you can see that tan is opposite over adjacent, and that corresponds to the gradient of the line that is making angle A. So therefore, tan A must equal 2. Likewise for tan B opposite over adjacent. Again, I'll just mark that on if you can see. But opposite here, adjacent here, and therefore that corresponds to the gradient of the second line. Therefore, tan B must equal a third. Now, the second bit says, without using your calculator, work out the angle between L1 and L2. Okay, so I'm just going to push that up a little bit. So what we need to do is we need to find this angle here. I'm going to call it angle C. Okay, now we know that tan A is 2 and tan B is a third. Now if you look at that triangle, okay, what you could work out is that angle C, okay, is A minus B. In the triangle here you can see that this one is B, this one of course is 180 minus A, and therefore you can work out that C is A minus B. Therefore, if I tan both sides, I get the tan of C equals the tan of A minus B. Okay, therefore tan C, I expand using one of the addition rules, I get tan of A minus tan of B over 1 plus tan A tan B. Therefore tan C equals, and if you remember, tan A was 2 and tan B was a third, so tan A was 2 minus a third over 1 plus, and then it's going to be 2 times a third. When you sort that out, you get that tan C equals 1. Okay, and of course C is the inverse tan of 1. Okay, C is tan to the minus 1 of 1. And you should know, therefore, that C is 45 degrees. Okay, quite a complicated question that, but again, really important that we got a good diagram. Right, now the next one says, in triangle ABC, AB is 5, angle ABC is theta minus 30, angle ACB is theta plus 30. Using the sine rule, show that tan theta is 3 root 3 if AC is 4 centimetres. So the first thing I've done is I've drawn a diagram. Right, so we're going to use the sine rule. So of course what we've got is the sine of theta minus 30 degrees over 4 equals the sine of theta plus 30 degrees over 5. It's just using the sine rule. We're going to first of all cross multiply. We get 5 sine of theta minus 30 degrees equals 4 sine of theta plus 30 degrees. If we then expand using our addition rules, so I'm going to expand the first one, so I'm going to get 5 sine theta cos 30 minus 5 cos theta sine 30 equals 4 sine theta cos 30 plus 4 cos theta sine 30. If you work out what cos 30 sine 30 are, you end up with 5 root 3 over 2 sine theta minus 5 over 2 cos theta, and that equals 2 root 3 sine theta, plus 2 cos theta. And all I've done there is worked out the values of sine 30, cos 30, and multiplied them with the coefficient of each of the terms. Okay, if you rearrange that, you end up with root 3 sine theta equals 9 cos theta. Okay, if you then divide both sides by cos theta, you get that root 3 tan theta equals 9. Tan theta equals 9 over root 3, and of course if you rationalise that, you get that tan theta is 3 root 3. So we've solved that one, and that's the end of the video for using the addition rule.